Okay, children. So coming to the topic, we'll discuss what are the different pressures in liquids, pressures in fluids. Children, wherever pressure, whether it is solids or liquids, pressure is same, children. Force acting on a unit area. Okay, so whether it is solids or liquids or gases, in all of the children normally when pressure is expressed in solids and liquids and gases, only liquids and gases we call them as fluids. Why do we call them as fluids? Can anyone say why liquids and gases are called fluids? Because they flow, because they flow, children. Liquids and gases can flow, that's why they are called fluids, children. Simple, children, if you take a water, a bucket full of water, if you push anything, it will come out, children. If you push anything, it will come out. That is called, this is also a type of push, a buoyant force, children. Okay, so what is pressure means? Normally pressure means force by area, we know. Okay, force by area. Pressure of a given liquid is given by the formula pressure is equal to force by area, same. Like in solids, force by area only. Okay, but what happens means here the what is the force means here what is the force means weight of liquid. Here, what is the force means weight of the liquid, and what is the A means area of base of vessel in which we are putting the liquids. Okay, so removing this both, children, we know P is equal to what is force, children? MA. Okay, force is MA, and this is area, children. This is area. Okay. Now, children, force is equal to mass into acceleration due to gravity, and this is area, children. So, children, mass means we know what, children. Mass means what? See, seriously, density is equal to mass by volume. So, what is mass, children? Can you say what is mass? Volume into density. What is mass, children? Volume into density. So, pressure is equal to what is mass can written as volume into density into acceleration. But whenever you are dipping in the liquid, we will take acceleration due to gravity. Okay, we will take acceleration due to gravity by area. Okay, children, by area. Now, children, volume means length into length into length. Okay, you all know that. And area means what, children? Length into length. This cone and LDG. The length means here. The length means height, children. In the liquid, the length means height, children. So formula for pressure is equal to HDG. Formula for H is equal pressure is equal to pressure exerted by the liquid is either you can take P is equal to force by area or P is equal to HDG. How you got HDG means you have to show this derivation in the exam. If I ask, okay, you have to show P is equal to HDG derivations, you have to derive like this. Now, what are the factors on which pressure in a liquid depends? Now, I will tell the laws, children. What are the laws? First one, children. Pressure exerted by liquid or the base of the container depends upon the height of the liquid column. Okay, so children, suppose here some height is there. Suppose here some height is there, children. Whichever has more height, and here you are keeping balloons. Whichever has more height of liquid column, that will exert more pressure, and that balloon will become bigger. Whichever has more height, that balloon will become bigger, children, indicating that pressure is directly proportional to height. Means as you go deep into the ocean, children, pressure of the oceans increases, weight of the ocean increases. So that's why as you go deep, children, you have to wear swimsuit jackets, children, which can withstand the pressure. So as you go deep into the water, as the water column increases, the pressure also increases. This is first law, children. Second one, okay, pressure is exerted on the walls of the container, children. Okay, when you put a liquid here, if you make a hole here, water will fall like this. They won't just slip like this. Water will fall like this. If you make hole here, it will also fall like this, children. If you make hole here, it will also fall like this. Means pressure is exerting on the walls of container. Pressure is exerting on the walls of the container. This is second law. First one is pressure, as the height increases, pressure increases. Second is walls of the container, pressure is exerted. Okay, children. Third one, children. Third one, pressure at a point liquid depends upon the depth also, children. Okay, means see, like see here, children. Suppose this is water. Okay, this is water bottle. Imagine here water is there. Here and here I will make hole. Which hole water will go and fall more distance? Can anyone tell? Here I will make one hole, here I will make one. There is a water is.
Sir, the lower one, sir.
Lower one will go and far fall, and this will fall like this because here pressure is less, here pressure is more. As you go deep, as the depth increases, pressure increases. As the depth increases, pressure increases. As the depth increases, pressure also increases. Okay, children. So, what are the three? Pressure depends upon the height of the column. More height, more pressure, and also pressure is exerted on the walls of the container. And as the depth is more, pressure is more. So first one, pressure is directly proportional to height. Second is pressure is exerted on the walls of the container. Third one is pressure is increases with the depth of the container, children. And fourth one, children, pressure of the liquid is same in all directions at a given depth. At a given depth, children. Suppose this is a bottle, okay? Okay, here at 3 centimeters, here at 3 centimeters, if I make a hole, this will fall equal distances, children. This and this will fall equal distance. Means at a given depth, the pressure is same at all points. At a given depth, pressure is same at all points. Okay, so these are the four laws, children. These are the four laws. Vedant, can you tell all the four laws? What is number one law? Pressure depends upon
Pressure depends upon the
height of the liquid column.
height of the liquid.
And pressure is exerted on
All sides of the container.
walls of container. Third one, pressure depends upon
Pressure depends upon the density.
depth of water. And fourth one, at a given depth,
Mm.
pressure is
And the
equal.
given
At a given depth, pressure is equal.
equal.
Okay, Meghana, can you repeat all this? What are the laws of pressure?
Pressure
Meghana.
depends on the height of the liquid.
Okay.
Pre-
Height of the
pressure
liquid column. Height of the liquid column. Here less column is there. Here more column is there. This balloon will bulge more. This balloon will bulge less. Okay.
pressure is exerted on the walls of the container.
Okay.
Pressure increases as the depth increases.
Okay.
Pressure depends on the depth.
At a given depth, pressure is equal at all points. At a given depth, pressure is
Pressure
equal
is
at all
equal
points.
at all
Raghuram,
points.
can you repeat all the points?
Yes, sir. Sir, pressure depends upon the height of the water column.
Okay.
Pressure is exerted on the walls on the walls. Uh, the pressure increases by the depth of the water.
Okay.
The pressure is equal at a given point.
At a given point. Next, Rishikesh.
Yes, sir. Sir, the pressure is equal. Sorry, sir.
Oh,
The more is the height, the pressure is the there is more pressure.
okay.
The pressure exerts on all walls of the container.
Uh,
Then pressure increases within the depth of the water.
no, pressure increases with depth.
Increases
And
in the depth
last,
of water. At the given point, pressure is
equal at all points.
all points. Yes.
Now, pressure is measured by anyone? Pressure is measured by simple manometer. Pressure is measured by simple manometer. Pressure is measured by. What is a simple manometer means, children? See here. It consists of a U-shaped tube. It consists of a U-shaped tube, children. Okay. Now, here scale will be there, children. Back of this scale will be there. Please see, children, construction. Back of this scale will be there. Okay. Normally, children, here and here, liquid column will be equal in both the limbs. Here and here, liquid column will be equal. Okay, so normally here and here, the liquid column will be equal. Now, what happens is when you want to check the pressure, okay? So, children, when you want to check the pressure, normally when both the tubes are open, see, children, when both the tubes are open, when the tubes are open, the height in each leg is equal. But if you exert some pressure on one of the leg, how we will exert pressure? A catch will be there, children. If you exert some pressure on one of the liquid, on one of the liquid, if you exert by using a pipe and a gauge, if you exert a pressure, then this side will go down and this side will go up. This side will go up. This and this, the difference in the heights gives the pressure at that point. Suppose this is say 80 centimeters you got. Suppose 60 centimeters you got. 80 minus 60 is how much, children? 20. So here 20 mm of Hg pressure we have applied here. The difference in the heights in this both columns, 80 minus 60, 20 mm of Hg pressure we have applied. 20. This column is 80. Imagine this column 60. 80 minus 60. Difference in the heights in the two columns. 80 minus 60 is 20 mm of Hg pressure we have applied. This is simple manometer and its construction. Okay, children. So now, children, normally, if you want to demonstrate air pressure, okay, if you want to demonstrate air pressure, children, you know what is a simple experiment we do, children? If you want to make measure air pressure, anyone knows? Simple experiment is there, children. Okay, take a test tube filled with mercury. Take a test tube filled with mercury, children. Take a test tube filled with mercury. Okay, children. And this is calibrated. Calibrated means measuring is there. This you pour here, children. You pour in this stuff. When you put in this stuff, children, all the mercury won't fall down, children. All the mercury won't fall. All the mercury won't fall. It comes to up to height 76 centimeters and it will stop. Those who did not understand, again I am saying, you take a trough and you invert the mercury containing mercury containing test tube here, children. All the mercury won't fall. All the mercury won't fall down. It will fall up to height of 76 centimeters and it will stop. Means indicating atmospheric pressure is 76 centimeters. Then you will get down. Sir, why it stopped, sir? Why, why it did not fall fully? Means because here atmospheric pressure will be acting on, children. This atmospheric pressure will stop it. Here atmospheric pressure, how much it is acting? 76 centimeters. How much atmospheric pressure is acting because of air? 76 centimeters. 76 centimeters of Hg. Normal pressure at sea level, children. Okay, suppose if pressure decreases at a given area, suppose instead of 76, normal 76, on earth we have 76, children, normal, that's normal. Atmospheric pressure is 76. Suppose at a given area, suddenly it is becoming, imagine 70, suddenly it is becoming 70. It indicates that that area will get rain shower. It is going to rain. If pressure falls abruptly, that indicates there is going to be a rain. Okay? All of you understood this experiment, or shall I say once again, children? Anyone wants me to explain this experiment again? Yes, children, anyone want me to explain?
No, sir.
Okay, children, so that is normally only, children. So here, children, what is happening is here 76 at 76 point on the earth at 76 centimeters it will stop, children. Why? Means on the earth the atmospheric pressure is on the earth the atmospheric pressure is 76 centimeters of Hg. Means the air is stopping it, children. Here, please see here, children. The air will stop. Air pressure will stop it. Air pressure will stop, and therefore it is 76 centimeters in on the earth, children. And the units of pressure, children, normally you can express in Newton per meter square. Newton per meter square. Newton per meter square or kilopascals. Or Newton per meter square, they will say pascals. In higher classes, you study, children, it is expressed in centimeters also. It is expressed in mm also. It is expressed in bars also. It is expressed in stars also. So many units are there for pressure, children. Pressure is expressed in Newton per meter square. It is also called pascals or kilopascals or centimeters or mm or bars or torsidy. So many units are there, children. So what is the definition of pressure? Pressure is force exerted on unit area. Force exerted on unit area. Here, what is the force, children? Weight of the liquid. What is the force? Here, this is weight of the liquid. And what is area? Area of the base of the container. Area of the base of the container. And I have shown you the derivation how you got P equal HdG. Means pressure depends upon the height. Okay, and pressure also depends upon density of the given liquid, and also pressure depends upon acceleration due to gravity. Pressure depends upon density also. Actually, to this I can add one more also. Pressure depends upon density also, children. Suppose water is there and oil is there. Which will have more density, children? Water or oil? Can anyone say? Yes. Which will have more density, children? Water or oil? Children, simple question,
The
children.
water.
Which will have more density? Water or oil?
Water.
Sir,
No,
water, sir.
oil will have more density, children. Oil will have more density. Oil will have more density. More density, more pressure will be there. Oil will have more density. Okay, water is having least density among all liquids, children. Oil will have more density. So more density, more is the pressure. Okay, children. So pressure depends upon height of the liquid column, density of the liquid column, even depth, even at a given depth it is same at all points, and is exerting on the walls of the container. What is the construction of simple manometer? I told. How to find the atmospheric pressure at that place? I told. Now we have to do some numericals, children. If you do numericals, then it means that you understood, children. Numericals also very very important. What we will do, children, for numericals tomorrow I will take, children, full class I will take. I will give 10-20 sums on the numericals and we will do tomorrow, children. Okay, did you copy these things, children? One second.